applications share some very common characteristics based on interaction. Most animation for games is done in short little segments, which are strung together as the game is played to give the illusion of continuous motion. Most games have a stock inventory of cycled motions that cover the basic needs of the game: running, jumping, standing, fighting, and so on. Moves must be short to preserve interactivity. If a player moves the joystick, he doesn't want to wait several seconds for an action to complete before the character responds. No matter how good it looks, the gamers of the world will loathe your animation if it takes too long to play back and spoils their control of the character. These cycles can then be combined to create longer animation sequence or just happen once and stop. Example is a first-person player reaction to pressing the forward button. The player run or walk cycle plays then stop and goes to an idle cycle waiting for the next input while the user manipulate the camera to look around. Cycles can also transition between each other through animation blending. A similar technique has been used by Disney as well at the time of Tom and Jerry or other cartoons where animations were drawing and colored in cycles, then moved and positioned during post-production to give the illusion that they actually move from one position to another. Animation cycles refer to the repetition of animations in a loop to simulate continuous actions or behaviors, commonly used in XR, extended reality, gaming, and other interactive applications. Instead of animating every frame individually, cycles allow animators to create seamless, reusable loops for repetitive actions like walking, running, breathing, or environmental effects. Other key aspects of a cycle is that it forces the animator to animate the character at a fixed location, which means that the character does not move forward or backwards too much in a cycle since it is expected to be positioned in an XR application at either random location or locations-based player input. Another important consideration is that of working with both left and right foot. In complete cycle, both legs need to be animated, an animation loop that can be played back multiple times. Key features of animation cycles: repetition. A specific set of animation frames is looped continuously. Saves time and resources by reusing a short sequence to create the appearance of continuous movement. Seamlessness. The cycle starts and ends in a way that transitions smoothly without noticeable jumps or interruptions. Efficiency. Cycles are lightweight and help optimize the performance of applications, especially in real-time rendering scenarios like XR. Interactivity. Cycles can adjust dynamically based on user input or environmental triggers. Types of animation cycles: movement cycles. Simulate continuous movements such as walking, running, swimming, or flying. Example: a character walking in VR will use a walking cycle that repeats as long as the user moves forward. Idle cycles represent subtle, continuous actions when there is no user interaction or movement. Example: a character breathing or shifting weight while standing still. Environmental cycles add life to the XR environment by repeating natural phenomena. Example: water waves, wind blowing leaves, or flickering lights. Interactive cycles triggered by user actions such as pressing a button or performing a gesture. Example: an object rotating while the user holds it in augmented reality. Components of animation cycles: keyframes, specific points in the animation timeline that define key poses or states. Cycles interpolate between these keyframes to create smooth motion. Timing and spacing. The duration of the cycle and how frames are spaced determines the animation's speed and fluidity. Example: a slow breathing cycle will have longer durations between keyframes. Transition points. Points where the cycle begins and ends must align to ensure seamless repetition. Benefits of animation cycles in XR. Performance optimization. Cycles reduce computational load by limiting the need for unique animations. They ensure smooth performance, especially on mobile AR/VR platforms. Realistic immersion. Repeating natural movements, like idle breathing or flowing water, enhances realism in XR environments. Dynamic user experience. Animation cycles can adapt to user inputs, making the interaction more engaging. Let's reflect on what we have learned so far.